Professor and Associate Dean in JP Institute of Information Technology, Sector 62, Noida. I am in Computer Science Department, but let me tell you, it's a native place for me. In 2004 October, till 2004 October, I was there in GCET, Computer Science Department, in your college. In 2004, I left for JIIT Noida, and from that time onwards, I am over here. But still, time to time, sometimes I used to come over here feeling the nostalgia of my old days, my young days. Okay. So, my background is that I had been, my graduation is in electronics and communication. Then I did my MTech in computer science and PhD in computer science, cloud computing, virtualization technology. And now I am more working starting from robotics to embedded system, then slowly moving on to cloud computing and then IoT based system. So I am in charge of IoT lab and IoT based systems also in JIIT Noida. So it's a blend of software and hardware both. It's a blend of software and hardware both. We know that academically we can go through many things like textbook or other such informations. Today I have come over here just to make you think or to give you a direction for planning your future and your career. In that way I have designed the things. It's not only for students, it's for faculty, it's for R&D people. We start with something very for each of the technologies and what will be the future for coming technologies. So this is known as Gartner's hype cycle. Gartner's hype cycle. You can have the hype cycle for emerging technologies. You can have the hype cycle for electronics and communication, for communication protocols, for embedded systems, for circuit designing, for Internet of Things, for cloud computing, for every area, for social networking. In any field you can have the trends, emerging trends, which is going to be tomorrow. Gartner publishes the trends for each and every technology, methodology, activity every year, and this is being published in the month of July or August. Okay, this shows, let us pick up for an example, this shows how the technology word, the buzzword arises or takes birth and how it goes on moving till finally it is in mainstream adoption. Till the final mainstream adoption, what are the troughs and crests which it follows through its life cycle, through its development? What are the things? So the trend is always represented somewhat like this. How it is, take for example, this is a generic one, we will try to see some specific one. Initially, whenever any technology takes birth or is invented or the name comes into picture, it's at this stage, trigger of the technology. There is a trigger of the technology, lots and lots of words are going on theoretically and in magazines and journals and papers and other media. So the thing is somewhat in a very blunt or rough way. It's available to the market if some trend is there. For example, let me give you an example of which you would be aware of. I think you are at the age of 18, 19 or something like this, 20. So 22 year backs in 1995 and 96, this mobile technology came into existence. That was the birth of mobile communication. Before that, if you talk to somebody 40 years back that tomorrow we will be having a mobile phone, we can carry that phone in our train, in our car, and they will look with surprise. They would have looked with a surprise. How is it possible? Not possible. That was the trend on that day. Oh, you can carry your mobile in your pocket and your phone in your pocket, and on the way you can talk to somebody. How is it possible that I can talk to the phone on my way to the train, etc.? That was a dream, not a real thing on that day. So that was this phase, 1995 for mobile technology, 96, 97. Then we started understanding that no sir, this has been developed. There is mobile, it has been developed by such and such US universities and it's in working. So people started dreaming what all things are there possible. Today we are able to talk only on we are having voice communications. No, you can do telegram also. You can send voice signals also. You can record it and send it. You can send pictures also. You can have video talk also. These things were imaginations. Today it's all free of cost. All communications are free of cost. You all are doing almost international call, you are making free of cost. So people went on imagining what all things can be done. So that was a mass media can also be transferred to mobile communication. So that was something unreal thing which people go on asking number of questions. But no, this can't be done. Slowly you go on to real things, what things are going to happen. Okay, so at this phase that disillusionment is removed. Illusion is removed. And then in their pocket some antenna sort of thing was there. They were treated as though special mobile is there in this pocket, great man. Something like this. Some of the people like me, we carried our mobile in our hand. Somebody is there, hello, means see I am having mobile. Something like this. So this was the trend. Today people go on hiding, putting it into, everybody is having. So this is the mass production and the real plateau of production is achieved over here. So this is the trend being adopted for every technology. Now say the same thing which we talked of has been put over here in details. Gartner. Let us see the real trend which has been published by Gartner. Emerging Technologies, which was published in 2009 and it is being published in the month of July or August. See, these are the technologies, emerging technologies. This was published in 2009. Why I am showing this? Try to understand this. Means in 2009, see this, dark blue color, sky blue color, something like this, all these colors, they indicate that if something is over here which is having a normal colorless sphere, Web 2.0 means within less than 2 years it will be in mainstream adoption. Then this color indicates that it will be in mainstream adoption in between 2 to 5 years. So look at this chart. In 2009 people would have looked at this hype cycle and they would get some direction as to where the future is moving. So see, look at cloud computing. In 2009 people were skeptical whether to adopt this or not. Many IT giants, they were trying to move on to cloud, but they were skeptical, doubtful. They did a from Gartner. Okay. So they are being consulted by many big IT giants or many companies to get the view what will be the future trend and accordingly they design. This one indicates more than 10 years. 2009, 2019. Today also mobile robots are not still in mainstream adoption because that was the prediction in 2009. You can have the hype cycle like this for 2010. See, IoT, go back, 2009, 8, 9, this buzzword was heard somewhere in the universities, but it was not open. So see, no words related to Internet of Things. Internet of Things is a blend of software and hardware and a knowledge of many more fields. Okay, so trying to come on to IoT, just trying to see the other areas of working. Then you look over here also, Internet TV has cropped up, wireless power has cropped up. Look at this point, this is something यहाँ पे obsolete before Pluto means there are many technologies which before reaching to the mass productivity in 2000 in previous years it was imagined that all bandwidth, all data will be communicated through broadband lines over the power lines, but it's not there. Wireless has replaced everything. So this went into a cold pack. This technology was born. Okay, so sometimes many technologies they become obsolete before coming. At this point of time, there is one advice I would like to give you, and I would suggest that share these advices to your friends also. It will help you to cooperate and move ahead. You can look at the height cycles, choose your area and see what direction you can move on, or whether your area of interest is going to be the future tomorrow or not. So that direction at least you can get from here. Okay, and accordingly if you move on, maybe you will be more successful as compared to the adopting other methods, and then since you are a hard worker you will take number of troughs and tests to reach at the success level. So better refer it, get some enlightenment and then move ahead in that direction. So see, now let us come to, so this was the hype cycle for emerging technologies. As I told you, this hype cycle is not only published for emerging technologies, it is also published for everything. Internet of Things, cloud computing, robotics, data analytics, whatever trends are going on. For everything this hype cycle will be published. So this is a hype cycle. I have stopped it over here. Let us see, for example, this one is the hype cycle for 2014 emerging technologies. Now we are having the hype cycle for IoT. Hype cycle only for IoT. Am I able to explain? Previous one it was for all emerging technologies. Now we are focusing on only Internet of Things. So we are having hype cycle of that also, because IoT is having different sub areas. Whether these sub areas will be in mainstream adoption, which area we should focus on, and so on. So all these issues are there. How do we focus on the areas, or what are our interests? How do we go on to that? So see, 2015 it was somewhere over here at the peak of inflated expectations, Internet of Things. Later on, we see that this IoT was quite comparable with RFID, almost same nature and same type of activity, RFID. Okay, so this has been shown that the technology period for RFID was somewhat like this, and it came into a Pluto of productivity at around 2016 to 18. This IoT it started in 2000, between 2008 to 10, and then by 2020 and 22 and little bit of onwards, it will be in mass Pluto of productivity. What does this say? We can conclude that tomorrow the world will be moving on in the direction of IoT, where technical contributions are abundant. Abundant amount of technical contributions are required from software people, hardware people, circuit designers, etc. Okay. In addition to these, even legal people, lawyers, and many other fields are there which are required in this area, in this IoT. See, this is the hype cycle for the year 2016. Different areas are there of IoT, what all things we can do. IoT integration, edge analytics. Have you heard the name? Edge computing, fog computing. Today, instead of is quite ahead of cloud computing, we are moving on towards fog computing and edge computing. We will see what these terminologies are. So let us see the recent one. This is the hype cycle published in July 2019 for IoT. So So these are the areas where the things are being worked out for Internet of Things. Okay. Just an idea to refer to any of the technologies of your interest and see if it can be of any use. But this is for sure that tomorrow the trend is going to be for IoT, and hence by IoT then other related activities. Because IoT and cloud can be combined together, because IoT, internet, means getting connected to other remote devices or nodes. How do we connect? Through internet. Then if we connect it, where do we store it? In the cloud. In the cloud means in the internet, and so on. So like this will move on. So cloud and IoT, these buzzwords go together. It's not something special like cloud is only for software and IoT is for hardware or something like this. We can't separate. The trend tomorrow is going to be collection of knowledge of all fields. Even environmental, bioinformatics or other such areas are supposed to be combined together to move on to achieve our targets tomorrow. So this is the trend. Now you see, look at this. This is the real data. In 60 seconds, throughout the world, it has been published by globe.com. In every 60 seconds, this much of activities are happening. Have a look to this one. 168 million emails are sent every second, every 60 seconds, sorry. 320 new Twitter accounts are created every 60 seconds. 50 plus WordPress downloads, Google searches, blogs, domains getting registered, and so on. So every 60 seconds these activities are happening. What do I want to say? I want to say that they are generating data. Lots and lots of data is getting generated because many things we are handling through internet. So lots and lots of data is getting generated. Some of the data is structured, some of the data is unstructured, some are even jumbled. We need a number of activities. So data, big data. IoT means Internet of Things. Things are nothing. Understand it in a layman's language. Anything which is a normal one, we make it smart. We make it smart. Our pen, we make it smart. We are going in the classroom, pressing it, recording the thing, sending to our friend, he is in the hostel, need not come over here. Study all the things we are having. So making anything, thing means the device, making it smarter. So we need to connect to the internet. So all things are there, we will see. Anything you can make smarter. Okay. So we'll try to move on. You would have gone through how these things are possible. Even today, we go on calling this is a smartphone. Smartphones means number of sensors, number of actuators, etc. are there. Have we ever studied as technical people how many sensors are there altogether in our smartphone? We haven't. Try to find out how many sensors are there. So these sensors, different types of sensors, and the connectivity, it is making your life better, easier, and implement it. Pick it up, implement it, you can do it. Whatever thing is there, you can make it smart. Sensors are there, actuators are there, other internet facilities are there. You use it and make it smarter. You can do it on your own. You imagine it. Why I am telling this? The only thing required at your level is think beyond the box. Our task is to make you excited or just make you trigger that instinct that you are able to think beyond the scope. And once you start, because you people are having I don't know how many times more energy than we old people. So that energy, if given a channelized direction, is going to serve the nation as a whole. Okay, so that is the direction we are going to get over here. Till here, I tried to inspire you to understand and think beyond the box. Now for IoT purpose, let us focus on to IoT part, Internet of Things. What all are the driving forces for Internet of Things? So the new sensor technologies which are being produced at a very, very cheaper rate, small in size and heterogeneous varieties of sensors available. So the technology has facilitated us to create a number of sensors for different purposes, and that too in a miniaturized form, different computing forms. Low power connectivity means if we are having, the requirement is that, as I told you earlier, that broadband lines, they become obsolete in the Gartner's hype cycle. I showed you. So that broadband line has become obsolete. It means the wireless technology has just taken care of those tasks. So this wireless technology, when we are having the devices in a wireless way, they are not connected. So charging them and giving energy to them, powering them, becomes quite cumbersome. So what to do? The first step is to design the circuits, to design the devices, the energy storage devices, energy. The other effect, there are tremendous indirect effects of designing these low energy systems. What is that? If we don't go on, we'll see, later on we'll see that per person, the number of devices connected today is more than 7. It's going to be beyond that. 50 billion devices are going to be per person, connected per person by 2020 or so. It means lots and lots of powers are required. Energy consumption is required. It means CO2 emissions. It means, I guess in the previous talk you have heard about green IoT. So this has given birth to a new area, that is green computing and green IoT. Take care of the systems, emissions and other, go on designing low power devices such that the carbon emissions or CO2 emissions are as much as possible they are reduced. Plus their life is extended, means power consumption. Lots and lots of works are going on in this direction also, not only at the circuit design level but at the software levels also. At the starting from circuit level to the software level, at all levels these things are being used. Then different types of mobile devices we are aware of, and since we need to connect these systems through the internet, of course we do require the power of cloud. So cloud, in a nutshell, cloud, IoT, designing the circuits, database connectivity and other such activities, these all go together. We have to join hands with all expertise areas. We have to join hands, we have to take help of all these people, and this is the reason today most of the organizations, they are trying to hire people who are having, first of all, as compared to the technical knowledge, they are having the skill to get cooperative work, do a work in a cooperative way, project in a cooperative way, so that you all can join the hand and develop it. Change in the network. One, I focused over there again, that broadband line. The way of thinking changed because of that, because of the technology, the way of thinking has changed. So the network, the technology, it also got changed. The network, the technology, it also got changed. So more number of connections are there, more number of devices are there. As I told you, anything can be made smart. And if anything can be made smart, what will be the count? How can we identify any device uniquely. We are having it uniquely, we can identify it by unique address. So what if each of the devices is made smart? This address will be true. So we switched on to another, we need to switch on to some other advanced protocols. What should be the protocols? And that too with the constraint that low power consumption must be there. That is the basic requirement. So we'll see what all things are there. So the future of the network, it depends on, we want IoT system, this is facilitating us to make the connections anytime, any place, and we want to connect anything. Anything should be connected, any place we want to connect it, and anytime we want to connect it. So see, on the move, outdoor, indoor activities, night, day, anytime, across the globe, different areas, PC, indoor, outdoor, on the move. Between what things? Between PCs, human to human, human to things, machine to machine, and so on. So this is what is the broad area of future networks. Some definitions are there for IoT. Let us move on to, we'll see, you can have this growing trend is that often referred as Internet of Things that we have already seen by the previous slides. So the question is, should we learn IoT? Yes, because tomorrow, as I showed you, if I would have showed you this slide in the beginning, there would have been a number of doubt in your mind. And that was the reason I gave you the research of Gartner's hype cycle. Now, I need not prove myself that these things are correct. No, the trend is moving in this direction. So I think you will easily believe that. So to make you believe this, those trends were showed to you, that understand this, that R&D has come to the conclusion that these things are correct. Business trend, emerging technologies, growing IoT services and applications, we'll see that yes, today we are in the mainstream. On the same trend, and that is a very famous one, Moore's law. Same trend, some researcher has showed that Internet also doubles in size in every 5.32 years. In every 5.32 years. Okay. And this is for sure. We'll see that it is growing at the rate of 5.32 years. Doubling. Now look at this. This is true. We shall move on to this one first. In 2003, 0.08 devices were connected per person. We see the world population was 6.3 billion. The total number of connected devices were around 500 million. So per person 0.08. Okay. I remember in around 90s or so, when we were bachelors of your age, so we stayed somewhere while doing the job. So our landlords, we go and ask them, we just namaste every time so that they may allow us when our phone comes from our home or some relatives or like this. Today, so no device, one home, 15, 20, 30 people were served by a single, and that too was not a smart device. So in 2003, the trend was that 0.08 smart devices were there. Then in around 2008, it reached beyond the number of people. Means connected devices were more than number of people. See, in 2010, 1.84 devices per person were there, and in 2020 it is expected to be around 7 devices per person. Count your number of smart devices to which you are connected. car is smart, mobile is also smart, then smart watch, then smart something else, then many such things are there which are smart. Okay, so PC is also smart, and so on. So now, when large number of devices, try to understand this. When large number of devices are there, are they going to give us ease or they are going to bring trouble for us? Car is also smart, mobile is also smart, laptop is also smart, home is also smart, and a single person is there who is picking up one of the devices, switch off the AC, switch off this mobile, switch off this one, just switch off that car, lock the car, check it out. Means everything that human being is going to take care of. They are shifted onto comfort zone. First of all, we try to shift the human beings into the comfort zone by providing smart devices. Now managing the smart devices itself is a challenge. 10 devices per person, how you will sleep? One device, this one switch it off, this one switch it off. No. So instead of sleeping, you will get sleepless nights. So the thing, people were forced to think that many of the devices must think on their own. They should become intelligent and smart enough to take the decisions on their own. And that is the reason. Otherwise, people go, means instead of having BP at the age of 50, at which I am, you get that BP, blood pressure high at the age of 25 or 30, 7, 8 devices, then boss is there, then office is there, home is there, everything. You are getting troubled. So instead of getting the ease, you are moving on to trouble. So at least these devices must become smart in such a way that they are able to take the decisions on their own. So to make them take the decisions on their own, some intelligent system devices must be designed, and that has given birth to machine learning, artificial intelligence and other such things to automate it. Take the decisions on your own and go on doing this. We want the car, not that much of smart but more smart, go and sit in that car, feed the location, forget it, it will drive to your office and back to home, something like this. So automating. Other such devices, your home, it senses that nobody is there in the house, switch off the AC, take the decision, let them take the decision. And these are the smart things which are part of IoT, that is Internet of Things. So move on to this part. I am moving on because these are from marketing point of view, what all things are there, where the trend is going on. Smart product sales are somewhat like this in $1 billion. This is the trend going on. Smart security like this in 2016. Smart education is somewhat this is the trend we are having, and so on. So let us not move into more details into these things. A realistic data, 20 quintillion, yani 10 to the power 18 bytes of data are produced every day. Data generation by the devices, still IoT is not at its mass plateau of productivity. In spite of that, every day around 10 to the power 18 bytes of data is produced. So you have to take care of. And these data are unstructured, semi-structured, structured to multimedia content and so on. Many things are there. We don't know. So data generation from different areas are being put over here. You can have a look in a laser time what all things are there, why these things are important. So let us now look at the real architecture of Internet of Things. This is the real architecture of Internet of Things. As I told you, when we call it by the name Internet, It means we do connect more than one devices through wireless or through internet. It means cloud is there in the picture. Big data is there in the picture. Okay. Artificial intelligence is there in the picture. All these things are combined together to achieve the thing. So from that point of view, instead of putting a theoretical IoT architecture, a practical IoT architecture is being put over here, looking at what all processings are being done at what layers. So look over here. Things are the devices, sensors, controllers, actuators, etc. at this level. Communication protocols, networks, M2M, Wi-Fi, telecom, etc. Edge computing things. So here we do something which is called fog computing. Later on we will try to see what is this fog computing. Fog computing. Then infrastructure, cloud infrastructure, we connect to the networks. So using some cloud infrastructure, and we call it as a cloud layer. Then when these data which are being collected from these things onto the cloud, it is being stored by internet or by other means. Now we need to process those unstructured data and unstructured textual or video or whatever form data is there. So we try to harvest it, we try to store it in a structured way and other such processings, etc. for our requirement. Based on the data, for example, in this room we see the data of the sensors. The sensors are blank. It's not, the infrared is not getting interrupted. It means no activity is happening. What does this mean? It means after X amount of time, switch off the trigger something so that the light is switched off, the AC is switched off. So you do need to have some mining of that data and use some techniques, machine learning and AI, etc. to take certain decisions. And then you design the applications in such a way that you sitting from here get all the things done on your own. Okay. In reality, if we separate it, these are some of the protocols which are existing, and I think we have gone through these protocols. OSI model you would have gone through, I guess. Computer networks. OSI model, 7 layers are there. In TCP/IP, 5 layers are there. Similarly for IoT protocols also, we are having this much number of layers, 1, 2, 3 and 4. 5 layers in TCP/IP model, 7 layers in OSI model, and 4 layers in IoT protocols. For IoT protocols, what are these things? Are they the same one which has been used till date, or they are something new? So what all things are there? At this level we are having GSM, CDMA, LTE, Ethernet, Wi-Fi, IEEE standards. This is at physical and data link layer over here. Fine, we will try to see this in a little bit of more details. Then at the network layer, as I told you, if we go for IPv4, 2 to the power 32 addresses or unique devices can be connected. Instead, we shifted on to IP version 8-bit. 128-bit means 2 to the power 128 number of devices can be connected. Basic requirement, now more number of devices can be connected to one network. Another thing is that since these devices are connected using wireless technologies, so giving power, supplying power to them is a challenge. So we need to design the protocols in such a way that they consume low power. So this is a special protocol, 6 IP version 6, short form means this special IPv6 is being designed, which is known for IoT purpose, which is known as the 6 has been picked up from this one. IP version 6, low power, wide personal area network. Okay. So like this, different protocols are there which are being put over here. So RPL is there, which is also a low power protocol. Then at the transport layer, since we are using the internet, we can't replace the existing TCP and IP because it is used for WAN, wide area network and other such areas, metro area networks and so on. Replacing the thing is quite difficult. So at the transport layer, we do use the same protocol, that is UDP and TCP. But at the application layer, special protocols, they all are moving around low power consumption, keeping in mind that low power must be consumed. Application specific low power consumption must be there. So at the application layer, some special protocols in addition to HTTPS, which is based on web services, existing XML family schema based HTTPS. In addition to that, we are having additional low power protocols, XMPP, COAP, MQTT and AQMP. These are the additional protocols for especially designed for IoT communications. So all together we have put all the areas over here. Cloud of things, Internet of things, tomorrow Internet of everything, and then cloud of things. All these things combined together. See, the cloud using Raspberry Pi, etc. We are using Nimbus, Gadgetiers, Arduino, TinyOS, etc. Then the protocols which we have used, we have seen over here. See, these are the protocols. So protocols, we are using special protocols, low power protocols. Then other at the lower level, physical and data link layer, we are using RFID tags, ZigBee, IEEE 802.15.4 is a special standard which is being used for IoT communications. They are having different developed at application layers. MQTT, this is what we saw now here, these protocols. So MQTT protocol is there, it works on publish subscribe model. Publish the thing, subscribe the thing. Then the other one is advanced message queuing protocol. Then extensible message presence SOAP. What is SOAP? Simple object access protocols are being used. Web services description languages are being used, and universal description and data integration. These things are used to connect to the existing methodologies of web services, and then redesign at the top level, at the application layer, without touching the middleware, so that low power devices and applications can be developed. As we are moving on, that is the main focus. So for this purpose, have you heard the name ZigBee? ZigBee. This ZigBee is a special alliance, and today it's exponentially growing. This is an alliance between different organizations, countries, which is being formed to develop low power devices. Now I think I should move a little bit faster. ZigBee is a stack of protocols, is a stack of devices to develop low power applications. It is an alliance where means non-profit organizations, different organizations, they are connected together. A new standard is being developed and it is being adopted by all organizations who are using the devices with this alliance, with these standards. See, these ZigBee applications are in the field of building automation, personal healthcare, industrial control, and all these areas, almost all areas. Okay, so what is this ZigBee? This alliance has, as I told you, they have developed their own standards. They have developed something that the speed of communication is a little bit of less, but the power consumption is very less. So 10K to 115.2 kbps data throughput is there. Then, as compared, what is the range of Bluetooth? Few meters, 5-6 meters or something like this. So we'll try to compare this Zigbee with that one. 10 to 75 meters is the coverage range. Then 65,000 slave nodes can be connected per network. 65,000 slave nodes can be connected per network. Then up to 100 co-located networks, and the battery life spans up to 2 years or more than that. So we can place the devices once and forget it for 2 years or more than that. These are the ranges which we adopt. Say 2.4 gigahertz ISM, it is being adopted worldwide. These are the 3 standards which are being adopted. 250 kbps, and this much number of channels are there. Then we are having 868 megahertz, which is only adopted in Europe with this much of speed, and channels are not required free of cost. No channel resolutions are required. 915 megahertz is being used in USA and countries. 40 kbps is the speed, and these are the number of channels which are. This is the standard throughout the world for all IoT devices. We are using at the base these things, these 3 standards. So this is the stand model. I'll move a little bit faster. These all activities we are performing over here. This is the Zigbee is placed at this layer on top of 802.15.4. This 802.15.4 is a special protocol which was having those 4 layers. We adopted those 4 layers, and based on the on top of that Zigbee network is placed, and this based on this we go on developing the APIs and Zigbee Alliance, etc. are being created. How do we connect? As I told you, a single master can connect 64K devices. So number of ways of connecting them is possible. Star, mesh and cluster tree topology. So say the main device is known as coordinator, PAN coordinator. So this one is the PAN coordinator. This is the star topology. This one is the PAN coordinator. The other one is FFD, full function devices. Not all devices are required to be full function devices. They consume more computational power is required, more energy is required, more resources are required. So limited number of nodes are designated as full function devices. So this blue color one is full function devices. Similarly, at the end nodes, at the edges, we develop the devices in such a way that minimum requirement computation is there, where minimum computational requirement can suffice to the application. So based on that, we do only that much of computations over here, so that power consumption is reduced. So 3 categories of devices are there: PAN coordinator, full function devices and reduced function devices. They can be connected in a mesh form, they can be connected in a star form and cluster tree form. So like this, the connectivity can be. These are the advantages of using this 802.15.4 frame format or the network type. What are these? One PAN coordinator and multiple reduced function devices or full function devices. Okay, 64K devices can be added to a single PAN coordinator. Means one coordinator is there, 64 into 2 to the power 10. This much number of devices can be added onto a single PAN coordinator. An IoT system can control this much of devices. Now, depending upon the range of placement of the devices, we do need to adopt the protocol or the Zigbee format. We also computer networks, fundamental computer networks. Have you gone through that subject? So there is a protocol named CSMA-CA, Carrier Sense Multiple Access Collision Avoidance. The CSMA-CA is being used in this 802.15.4. Okay, and the data delivery is reliable. These devices, RFDs and FFDs, reduced function devices and full function devices, they can be connected together, means they can be associated, they can be disassociated dynamically as and when required. So this is the smartness, this is the beauty of this network. Very frequently they can get added to the network. There are some trends. Very frequently they can be disassociated with the network. So power consumption, depending upon the requirement of the power, dynamically the things, the nodes can be added and disconnected. And then AES 128-bit security is also available. Okay. So how do we design the sensors? How do we design the sensors? Thousands of sensors in a small space, we do need to connect that, so wireless is required. But sensors are frequently standalone. It means can't be charged at everyone now and then, so low power. And then isolated in nature, moderate range, so that low power consumptions are there. So these are the challenges while designing by the design experts. These are some of the challenges, but with time to time it will be addressed. You'll see that. This architecture, this range we have seen. So these are the packet formats for 802.15.4. This is the packet format. Preamble is there of 32-bit, limiter, packet delimiter is there of 8-bit, and then the physical header is there of 8-bit, and rest of this is physical service data unit, 127 octets. Octets means 127 into 8. Okay, this much number of bits are being used for data transfer. This is the architecture we are using. These networks we have already seen. Now say full function devices, they are having the property, they can adopt any topology, star, mesh, any topology. Okay. Anytime any coordinator can be shifted on to full function device, and any full function device can act as a coordinator depending upon the dynamic requirement. Okay. It can talk to full function device, can talk to any device. Whereas the reduced function devices are limited only to star topology. They are limited only to star topology. They cannot become a coordinator. Only full function devices can become coordinator. That is the restriction, that is the constraint. Range. This Bluetooth also works. So first of all, look at this one. What is the complete features and comparative feature between Zigbee and Bluetooth? Bluetooth we are using to do the data communication we are having. Okay. So the question would arise that why don't we go for Bluetooth as compared to instead of Zigbee? Why we are going for Zigbee? We are already having this Bluetooth communication, Bluetooth protocols or technology. So this is the comparison. Now it's very much clear. If you look at, first of all, the power profile is within days. Bluetooth device, you charge it, within few days it will be discharged. But you need to have the devices in such a way that they should span even many years. So the span of Zigbee devices is many years, and this is for days. Complexity, Bluetooth is complex, Zigbee protocol layers very simple. We have seen that. Okay, node and master, how many number of master-slave connections are possible? At the most 7 devices. One master can connect to, one is the same one, 7 more devices, slaves can be connected. Whereas in this one, 64K, one master can have 64K devices. So what this will facilitate, we don't have to go for 128-bit IPv6 addresses always. Make one coordinator assign one address to this coordinator, connect 64K devices to this coordinator. Locally it can handle it. Locally it can handle. Today is highly adopted. People are shifting onto this standard. They are joining this alliance in a very frequent way. The growth is exponential. And see, range 10 meter, Bluetooth device 70 meter to 300 meter. Extendability, no, yes, it can be extended. You can go on adding the thing. 1 megabits per second. Here, since the devices are low power, their capability of data transfer is reduced, because we need to design that, and this requirement, this data rate requirement can suffice the application requirement. 250 kbps will suffice all normal requirements of devices to make it smart. You don't always need a big IBM mainframe to do the computations altogether. We don't know, we are not aware of, even we are not using more than 15% of the computational power of our laptop or any of the machine. That is at the higher level. We use 7 to 10% of the computational power of our devices. Means more than 90% of the power is getting wasted. Okay, so in the same way, if availability of bandwidth is there, we are not using and more power is being getting consumed. So why to go for that? So this can suffice our requirement, and at the security level also 128-bit AES is there. So this is the reason for adoption of ZigBee technology. Cloud-based IoT platforms are there that you can see. This table you can study on your own. I'll put the slide over here. So this is the combination of all these things. All together, combination of IoT, AI, big data, cloud, and then IABC putting together. Have you heard the name SDG? What I have spoken, I don't want you to believe that. Don't believe me. See where the world is going. Have you heard the name SDG? Sustainable Development Goals. United Nations in 2000, in the year 2000, United Nations where 169 countries are there, member of that United Nations. You have heard the name of United Nations. So this developed a goal known as Millennium Development Goal in the year 2000. And that goal was to be achieved by 2015. By 2015. Why I am discussing this? This will give the direction for future things. This is the requirement. So, United Nations, it formed and developed that consortium of United Nations in the year 2000. They decided 7 goals. They defined 7 goals which was supposed to be achieved by 2015. And in 2015, in 2016, again it was revised and it was found out that to quite an extent the goals were achieved but not fully. The reason was because of poor economy of many countries, because of natural disasters and many such things. So in the year 2016, these goals were redefined and 17 goals were defined. And these are the 17 goals. 1, 2, 3, 4, 17 goals. These goals are having 169 targets internally. You go at this website, visit it, and you will understand where it's not like government of India is declaring that women is being empowered, so they are doing on their own, and this ministry and this government is doing on. No, sir. That is the direction from the United Nations. They will have to give importance to women equality, gender equality. They will have to follow that. If not, IMF funding will be either hindered or stopped. So they put in their own way, this I am doing, and whatever things are there. But the world is forced to move in this direction, else they will not get support. So whosoever is coming one way or the other, they twist the things and put it into implementation. So these goals are to be achieved by the year 2030. You just go and look at it, 169 targets are there. Out of these goals, 5 SDGs are directly related to IoT projects. 5 sustainable development goals are directly related to IoT projects. Others are also related, micro, small, all these things, different goals. See the areas, in which areas they are directly related, all these things are being mentioned. You see, it means IoT is again going to be the trend for tomorrow. That is the direction of United Nations, and I told you the reason for adoption by almost all countries of the world. They have to move in this direction. The consortium says that. A story is there. Sir, how much time I am having? I am having half an hour. Do you know one truth about India? Have you heard this story? Have you heard this? Say in Mumbai, some posh area is there. In that posh area, the supply of water is 37 times lesser than that which is there in Dharavi. Dharavi name, have you heard? Dharavi is the cluster, basti of poor people, the laborers, the workers. They are paying 37 times more price for water for what posh area people are doing. And they are aware of that. This is the reality today. This is happening. You know why? This is the reason. Cost of delivering utility services to the poor neighborhood is very expensive. They can't connect the lines. They can't connect the things. The poor must be given more facility, and it's vice versa. People will not focus on these things. So today you see, when you ask the students to move on these IoT directions, many number of students are doing the projects. Why can't we design a smart dustbin? Why can't we design some smart refrigerator where everybody will come and store the leftover foods collected and transferred on to sustainable development? Means, what does sustainable means? Sustainable means whatever you are doing today is in any way is not impacting the future generations in a negative way. It should not impact the future generation in a negative way. Today I am purchasing a Mercedes car, running here and there, pollution. Tomorrow you people are there, the children are born, they are having some airborne diseases, lung diseases, all by pollution, because of pollution. Design an electric car or a green IT car, something like this. So many things are there. Many things are there which are contributing. Sustainable means whatever you are doing today is not impacting the future in a negative way. Okay, so these IoT systems can be developed to connect the things in a wireless way so that the things reach over there in a smarter way. Tangaliyan, some limited areas are the pipelines can't be carried on to that area. Number of constraints are there. It's not like since they are poor, that's why they are neglected. Some constraints are there. Those constraints can be overcome using Internet of Things. Many solutions are already posted on many dashboards. You can see that. So this IoT will, with the ability of IoT to sense, collect, transmit, analyze and distribute data on a massive scale, humanity will have the knowledge and wisdom it needs not only to survive but to thrive. Not only to survive but to thrive. There are certain hurdles also, but that is for sure that these hurdles will be worked out. It's only a matter of time. It's only a matter of time. So this was one part. Now by Arduino sensors, have you worked on these things? A little bit of. Have you heard the name Node-RED? See, purchasing Raspberry Pi, working on that is very good. Raspbian OS etc. you have installed, and then you would have connected to ThinkSpeak वगैरह. उस पे भी काम किया? No? Arduino. See, these hardwares are available. Based on that, the sensors are connected. These sensors data can be transferred onto the cloud, and we can analyze the data and do all these things. The software only solution means all these things. We are having some tool known as Node-RED. This Node-RED is a simple JavaScript based tool where all your hardwares can be connected. Your Raspberry Pi can be connected, your Arduino can be connected, your sensors can be connected, temperature sensors, pressure sensors, other precision sensors, all these things can be connected together, and the data can be stored, analyzed, processed, sent on to the internet, can be Twitter, can be sent on social media, sentiment analysis, and all these things can be done using this Node-RED. So we'll try to run some simple application onto this and try to see how it works. Let us see, explore it. It is open source, free of cost. You can use it. As much you go into the details, that much you will learn. All tutorials and everything is available free of cost. The only requirement and only one requirement is that you need to install Node.js. Node.js install कीजिए. Then you need to install Java JDK Node.js, and then you install Node-RED. How to install it from that point to how to run it, I will go to that point. Okay, starting from what all things it can do. It's simple program, it can be written in JavaScript. So let us see why this was designed. The main problem was that we required a tool that make it easier for developers at all levels to bring together the different stream of events, both physical and digital, that make up the IoT. Okay, so this was the basic requirement. So we used JavaScript. Earlier in 1990s, this JavaScript was having a limited application for web designing or web page or Java page developments. Later on, they were made and they run very slow. They were running very slow. Today, it has been modified and developed in such a way that the pages have become very light and it runs very fast. The JavaScript is executed very fast and runs in the background of many client-sided web applications. In many of the cases, JavaScript we are using to run it. And the other main advantage is that JavaScript engines can nowadays also run outside the web browser. You need not have the web browser. It can run without the web browsers, and that was the requirement. That is the requirement. So Node.js is being used. We install the Node.js free of cost using, then it's having the HTTP server at the background. Okay, 5 lines of code can run a server. We can run a server in 5 lines of code. NPM module is there. It is having 50k plus packages, libraries, etc. in package. All the things we can use it. We'll see that. So all devices, Raspberry Pi, Arduino, and other such devices can be connected. ARM microcontroller 8051, all the things can be connected onto this Node-RED. Okay. So GUI is available. We can do it without having any internal details or any internal understanding of the background layers. We can use it. Large number of libraries. How many of you have worked on Raspberry Pi? Raspberry Pi is having GPIOs, graphical processing I/O. units are there, different pins are there. So those pins can be connected to get the output interface to different devices, LEDs or whatever operation, whatever sensors you want to connect to. Okay. So these things can be connected to this node RAD. I am not getting any amount or any price or any money from this node RAD, but I am doing this advertisement. No, it's not advertisement, it's a free tool available to you. You can use it for academic purpose. It's very nice, and as much you explore, as much depth you adopt, you will go on learning to that. Having lots and lots of tools like Linux. Linux is a powerful operating system in a similar way, having number of packages in the similar way this node RAD is having. And we'll see how easy it is to use this. It looks somewhat like this. It looks somewhat like this. We can have different, you see, this is the message. Here some function is there. We process it, message 1, message 2, single input, multiple output, multiple input, single output, multiple processing zones, multiple functionalities, all these things can be connected together. Okay. Somewhat like complex examples of network or flow of node RAD is here. This we can achieve. This we can also get. The prerequisite is that this is important. Prerequisite is that we should have Node.js installed. We should have Node.js installed, and then using this command we can run this node RAD. We can run the node RAD. So it's getting installed. If we want to write the first program, since we are trying to run it on our local system, use localhost, and then this is the port number at which it is defined. This is the port number at which it is defined. Suppose, for example, you are running this node RAD on one system and connecting to another system. At this very part, you will have to give the IP address. What is the IP address of local system? 127.0.0.1. This is the IP address for local system. 127.0.0. Instead of localhost, if you give this is the URL name now. If you give the local IP address, the local address is always 127.0.0.1. So it will get connected, and then you can run the details, do all these activities, and you can see the output somewhat like this. So let us, instead of looking it at this point, let us try the D drive, C drive, whatever it is. Node.js is installed. Then node RAD folder, it is again open source, free of cost, available to you. Go in that folder, run this command. Once you are running this command, you see the server will be started. So the server is started. It goes on verifying different things. IP address, are you able to see what is the address? 127.0.0.1. This is the local address always. If you want to run it on one address and connect it, is it fine? So now over here 127 over here. Let me remove these things first. Delete it and message payload deleted. Okay, now let us try to design a connection. You don't have to do anything. You first node, just drag and drop it over here. First thing, we haven't done anything. Okay, then this is the input now. This is the input. For output we want something, so pick another palette from the output. You have put over here. Nothing I have done. Connect this one to this one. Input and output is connected. We want some output. Now make some GCET FDP. Fine. I pick up two more things in the slide. Simplest application. Now, timestamp. What do you want to do this? You want to display this message. You want to display this message only once, or on pressing the tab, or this is like designing some IoT-based system, or you want it after certain intervals. All these options are available in this tool. So suppose we want the timestamp. Timestamp is okay. We are having of interval. How much interval? How much interval we want to have? Say every 3 seconds. Every 3 seconds we want to print hello. Okay? So done. Done. If the things are not fine, here red mark triangle will be there. If they are properly configured, that green mark will be there. So once the things are connected, you deployed and you see you got it deployed successfully. Hello GCET FDP 3:22:56 after 3 seconds 3:22:59. Hello GCET FDP. Other things I have not configured. We can configure other things also. I will see what all things we can configure. Something like this. So all things are there. Delete this, start from the beginning. So every now and then the message is getting displayed. Now this is the simplest part. Just to say hello and something like this. You can perform this much number of functions. Functions are there, templates are there. You can create delays, comments, HTTP request, TCP request, switching. All these activities can be performed. It's having a huge list. You can split, you can join, you can pick the database from different sources. .csv file, you can connect to that. You can connect to the Twitter, you can connect to JSON, XML data, and see. You can connect to social media. From here you can send the email. From email you can get the data, process it over here. Email, Twitter, storage of the file can also be done. You can do sentiment analysis. And then other such activities can all be performed over here. For example, if you want to connect to something, if you want a function to be added to this thing, you can connect it. You can generate a random number, write 2 words code, random bracket 100 below. It will go on generating random numbers below 100. Randomly it will go on generating. Like, okay, you can connect Raspberry Pi, you can connect everything onto this one. You can connect Arduino, get the results, you can connect the sensors, etc. and see the results. So that connections will have to be done onto your this node. The Raspberry Pi etc. will have to be connected onto this. The data can be transferred from there to the sensor. It can be filtered from here, processed over here, sent on to the cloud and interface to any network, Twitter network or any other social media, Facebook etc. It can be done. Okay, you can explore it. So this is what is being discussed. So the server keeps on flowing. The moment you close this server, all the communications will be stopped. As long as you want to do the communication, the server must run. So I am stopping it, things gone then. Now it will gone. So this is how the things are. Now what I have explained over here, the same things are being put over here in a slide. All these notes and their explanations etc. What all things we can do over here, and this is how the thing is. Thank you very much. Any questions please?
Thank you so much sir for sharing your knowledge on IoT with us. Now I invite Dr. R.L. Yadav sir to present a memento.
Thank you, sir.
Sir, नहीं आपकी नहीं please.
हाँ वो हम लोग कल हाँ